Good morning, students. This is our exercise number 3, Introduction to Data Science Lab. The third exercise is to write a Python program to demonstrate the data visualization for data science applications. Data visualization plays a major role in the data science applications. We can easily understand how the data is spread among the entire range and what is the mean value, median value. All the values can be easily interpreted by using this data visualization concept. In this concept, we are discussing some of the data visualization techniques like charts, graphs, then box plot, histogram, all these things will described in this video. And before doing this experiment, we know that first you have to import the pandas. Pandas can be imported using the normal technique, import pandas as PD and import the NumPy array also. It will be helpful for some applications. And one of the main panda library used for data visualization is the matplot library, matplot. So when you are going to, there are so many library functions available for plotting. But in this example, we are discussing about the matplot library. So import the matplot library before doing the experiment. Import matplot library dot pyplot as plot. Here I have created PLT object for this matplot library. I'm importing all the library functions like scatter plot and box plot. Everything can be taken from the matplot library. The first question is, I have imported all these things, import pandas, MATLAB and matplot library. And for simplicity, I have created the 2D array from the given data, and from the array I created the data frame. This is the array with 6 columns, and first column contains the employee ID, next one is the gender, the next one is age, sales, BMI and the income. All these values are given for 10 different persons. And this, by using this array, data frame is created. I just created the data frame here. I created the data frame with the data frame name DF, and this is the created data frame. And the column names are employee ID, gender, age, sales, BMI, and income. For the given columns, I am going to plot all the graphs, charts, as well as the histogram. So this is my data frame. First one is the line chart. As we know that line chart gives the relationship between how the data is varied from low level to high level values, that is given by the line plot. When I am seeing this age is from 34, 40, 37, 30. These all are the age values. All the age values are plotted by using this line chart. If I am not specifying anything, just plot the line plot means only the columns with numerical values plotted. Here the columns with numerical values are age, sales and income. These three are the columns with the numerical values. If I am simply plotting that line plot or the dot plot means these values are plotted. You see here I am df dot plot without specifying anything means that in default case that's taken as the line plot. By default this is considered as the line plot, and I am executing this one. You see that this is the line plot. I already told you there are age, sales and income are the numerical columns. So this is displayed for age, sales and the income value automatically. Here I am not mentioning any columns. Without that column also it will be displayed. Suppose I want to display only the age column. How the age column varies depends upon the employee details, how it varies. I want to know the details means I will plot the age column only. Here I am plotting the columns. You should specify the names of the column. Here I am plotting employee ID as well as the sales. So it means I am plotting the line graph between employee ID and the sales. Look here, employee ID as well as the sales. Employee ID is the not a numerical value, that even though it's not a numerical value, I can plot this one. Here I'm going to plot this one. df dot plot of expand this one. So df dot plot of employee ID and sales. For these two columns, I'm going to plot. And here I mentioned that line width and marker as well as color. I'm executing this one. See that plot. In this plot, I have given the plot dot x label equal to employee ID. X label and Y label can assign by the user. X label is equal to employee ID as well as the Y label is equal to sales. Similarly, here I have specified the line width, marker and color. Marker indicates the positions at the point. Without this marker also, I'll plot this one. Suppose I want to plot the dot plot, not the dot plot means simply I remove the line width. If I am giving the line width equal to 0, that will be a dot plot. It contains only dot. If I am giving the line width, the line also can draw between all the points. And marker is star, I can change this marker also. Whatever I want, I will use this marker also. It's also possible. Without marker also, it's possible. And color equal to red here. Color is red. I'll change that as color is equal to blue. That is also possible. With default values also, I'll include this one. If I'm not giving this one, then also I'll get this. Without that marker also, I'll plot this one. Similarly, red means the color is changed to red. Without the color also, I'll plot this one. Without specifying the color also, I'll plot this one. Default, it will display in blue color. And line width also, I'll change the line width. Here, if I'm giving 3 means, we'll get the line plot with this thing. That is also possible. So, I can give the color, I'll give that marker. Everything is not mandatory. If you require, you'll place that. This is a lot about the line charts. The next one is bar chart. Bar chart is very, very important. Bar chart is used to compare the two values. By using the bar chart, easily you can say how the data points are scattered or how the data points are spread over the entire region compared to other thing. If you are simply plotting plot dot bar means it's plotted. It's also plotted for the numerical columns. The numerical columns age, sales, and income. For that, the bar plot can be viewed for this one. Okay. So this is the bar chart. Here, 3 columns. For all these 3 columns, the bar plot is drawn. And from this one, the first one is age. So the difference between age, sales, and income, all the details can be found out using this bar chart. Again, if I want to plot the bar chart for 2 columns age and income, that's also possible. Here I am plotting the bar chart for age and the income. The x-axis is age and the income. Between age and income, between 2 rows and columns also, we'll draw the bar chart to compare this one. Same way, we'll change the color. Bar chart can also be drawn with a specific color. Use a specific colors. This is also applicable to the bar chart. This is the what called as the vertical bar chart. All the values are arranged in a vertical manner. Similar way, we will draw the horizontal bar chart also. To execute the horizontal bar chart, here you should give bar H. Okay. Plot dot bar H. It will give the horizontal bar chart. I'm between age and income. I have plotted this between age as well as the income, and this is the horizontal bar chart. And next one is the stack bar chart. Stack bar chart means one after another one, right? Stack one top one thing is available in the top of another things. That's also possible. That is, I'm going to create a same thing, sales and the new sales. I have created the sales and that's the new sales. For to display that one, the new sales is created. New sales column is created from the existing sales value. That is sales plus 100 gives the new sales value. Now I am plotting the the bar graph between this sales and the new sales, sales and the new sales. So that is what called as the stacked bar chart. The x-axis is age and the sales. Here I am comparing the age and the sales, and also the sales as well as the new sales. These two are taken and that is added in this bar chart. This is what called as the stacked bar chart. Here also I will specify the color to indicate the difference between the bar and the stacked bar. You see here I am using this income as well as the sales. Bottom one is sales and another one is income. By using this kind of bar chart, within a single bar chart itself will compare age and the sales as well as income, how it deviated. That can be seen by this bar chart. And next one is this same thing, plot between these two things. And another one is box plot. That is very, very important. That is the pictorial representation of the describe statement. I think you all remember the functionalities of the describe statement. What is the function of the describe statement? It will give the statistical information about the data frame. Similarly, to get the statistical information about the data frame, we will go for this box plot. Box plot will use the details of the statistical information of this data frame. That is given by the box plot. Box plot here I am using df.plot.box. If I draw this one here, I am not specifying any columns. The columns are not specifically given. The box plot for all the columns are marked here. The box plot can also be drawn only for this numerical column in our data frame. There are three numerical columns. The numerical columns are age, sales, and the income. So all these things, this age, sales, and income. Now I have created one more thing, new sales. Hence, for all these things, the box plot is created. And from the box plot, we'll find the minimum value, maximum value, and this quartiles, 25% quartile, 75% quartile, as well as the outlays can also be identified by using the box plot. Outlays means consider here. This is the box plot for age. Suppose so consider DF. You see this data frame. Here age is 34, 30, 40, 37, 30. This is the age. For this column, I have drawn this plot. Here, all the ages are from 26 to, it varies from 20 to 26 to 44. 44 is the highest one, that is somewhat deviated from the existing data. If the data is deviated from the existing data, that is called as the outlier. In our example, 44. 44 is deviated from the existing data, and hence this is the outlier. The outliers can be shown by this kind of bubbles. That is the data deviated from the existing data. That is the data that is far away from the mean value. That is considered as the outliers. By using this box plot, we can identify the outliers also. Here, this is the minimum value. This one is the minimum value. This is the maximum value. This one is the median value. This 35 is the median value. And this is 75% quartile. And this one is the 25% quartile. In display all these values, you'll get the accurate values. So box plot is used to find the statistical information about the data. And next is pie chart. We know that this is the pie chart. And pie chart for age. Here there are 10 columns. A, B, C, D, E, F, G, H, I, J. I am giving the name like this one. 10 different age groups are there. For all this age, the age are displayed by using the pie chart. I'll give the values also. Pie chart, the values can also be displayed. And labels can also be displayed. This is the pie chart for the age. Different age groups is shown in different color. Similarly, you can create the pie chart by grouping the values, group the values, and for each and every group, based on the value also, you can create the pie chart, write out. And next important thing is the scatter plot. Scatter plot is used to give the correlation between two variables. The correlation between the two variables can be identified by the scatter plot. Here, this is the scatter plot between income as well as the age. When you see this one here, there is no correlation. All the values are scattered over everywhere. This is almost like a dot plot. The difference between dot plot and scatter plot is it will give us the details that are same only. But in our example, we are using the scatter plot to identify the correlation between the data points. In the scatter plot, if the x value increases, y value also increases, means the plot is like that, means that is what called as the positive correlation. And if the x value increases, y value decreases, means that is called as the negative correlation. We can't find any relationship between the x value and the y value, means that's known as there is no relationship between the data. Here there is no relationship between the data. Just check in your data set whether that is the positive correlation or negative correlation and write that also in your observation. And the next one is the histogram. Histogram gives the frequency of occurrence. So always the x-axis of the histogram is the count and the y-axis is the count and x-axis give the value. How the data is, how frequent the data is available. For example, in the age 44 means how many times 44 is available in the data frame. How many times 26 is available in the data frame. That is given by the histogram. The histogram also, this is given by df.hist. This is used to draw the histogram. If you are not specifying any column, the histogram of all the columns, all the numerical columns will be displayed in our data set. I'm not specifying anything. I am not specifying anything. All this age, sales, income, new sales, all these values, the histogram is here. These are the histogram. From this one, new sales, the sales is lies between 135 to 140 more. And there is no sales in this region. Entire data distribution, the number of frequency occurrence of the data is identified by the histogram. And there is one more kind of histogram called as probability density histogram. In this kind of histogram, instead of the values, generally the values vary from 0 to anywhere else. To normalize the value, to find the normalized histogram, you should plot the histogram between 0 and 1. That can be done with the help of the probability distributed histogram. And in the histogram, we will divide the bin numbers also. Number of bins can also be given by the user. This is the histogram of age. We'll plot the histogram for age, sales, anything. Separately also, we will plot the histogram. And then this is the histogram with bin values. Here I am specifying that density equal to true. That means that is the probability density function. And when you see the histogram, the leftmost values always lies between 0 to 1 in the probability distribution histogram. And bin values is given as 9. So in this histogram, 9 bins will be there. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's divided into 9 bins. The bins can also be divided by some colors. Bin colors can also possible here to try it with bin color. So these are the various types of plots available in the data science. Basic plots available in the data science application. Histogram, then line plot, bar chart, box plot, scatter plot, pie chart, stack bar chart. These are some of the charts and plots available in this data science application. Thank you.